Alright, so for number 2, they want you to compare the three functions, and what I did is I graphed them, as you can see, the different colors. And so when you compare all the attributes, they have the same domain, they have the same range, all three of them have the same end behavior, they have the same vertical asymptote right here on x equals 0. All of them are increasing. All three of them have the same positive interval and the same negative interval. In other words, from 0 to 1, they're all negative, and greater than 0, they're all positive. And they also have the same x-intercept, 1, 0, and none of them have a y-intercept. The only thing that's different, that they have different, is the rate of change. Because notice how log of x is flatter, so it changes slower than log base 2 of x, which is steeper, so it changes faster. And then natural log is kind of in the middle. Okay, and that's all they wanted you to write for this one. Okay, so for 4, the f of x function is like the parent function, log base 2 of x, and the green function is the g of x function. And so here are the reference points. H is negative 2, so that's why you subtract 2. A is negative 4 and K is 1, so that affects the Y. These are the transformed points right here, and again the yellow line is the vertical asymptote, which is x equals negative 2, which is the same thing as the H value. And here are the here's the graph for that. They also want you to describe the transformations in this function, in other words, from here to here, what happened. So you're going to say, just like we did at the beginning of the year, you're going to say vertical stretch by factor of 4, reflection over x-axis because it's negative 4, and then left 2, up 1, and this is the translation. The domain for g of x is from negative 2 to infinity, and the range is all reals. Okay, so here's the rest of the analysis. You've got horizontal asymptote, the end behavior. As x gets bigger, f of x gets smaller, and as x approaches negative 2 from the right, f of x goes to positive infinity. Now the y-intercept is right here, I just got it from here, and the x-intercept, remember you set g of x equal to 0, and so you get 0 equals negative 4 log base 2 of x plus 1, plus 2 plus 1, so the 1 moves over to the other side, and you have this, log base 2 of x plus 2, divide by negative 4, so now you have 1/4 equals log base 2 of x plus 2. Change it to exponential, so it's 2 to the 1/4 equals x plus 2, subtract 2, and then you put this into the calculator, 2 to the 1/4 minus 2, and that's where you get approximately equal to 0.8, negative 0.8, sorry. Okay, so g of x has base 10, and so these are the reference points right here. This is the transformation that they're going to go through, and so when you do that, this is what you end up with. This graph right here is the log of x, so it's base 10. Okay, the parent function, no transformation, so now I'm going to plot the points that we have here. But first let me draw the vertical asymptote, which would go here. And then the points 1 1/10, negative 4, and then 2, negative 1, and then 11, 2. Okay, this is g of x. And what it did is it has a vertical stretch by a factor of 3, and then the translations are 1 right, 1 down. That's a 1. Okay, the domain is all reals. Sorry, backwards. Take it back. I'm thinking of exponentials. Domain is from 1 to infinity. Range is all reals. Horizontal asymptote is x equals 1. And behavior is as x approaches infinity, f of x goes to infinity, and as x approaches 1 from the right, f of x goes to negative infinity. For intercepts, replace the g of x. We're going to do the x-intercept. Replace the g of x with a 0, and I'll do the work here on the side. So you get 0 equals 3 log of x minus 1 minus 1. So you move the 1 over this one. So you add 1. Then you divide by 3. And so now you have 10 to the 1/3 equals x minus 1. So you add 1. So x is 10 to the 1/3 plus 1. That's the exact value. So this is approximately 3.2 when you round it. So the x-intercept would be 3.20. For the y-intercept, you make the x equal to 0, but you could see from the graph, it's not possible, right? And if you were to put it into the equation, x over here, 0 minus 1 is negative 1, it's not defined, it doesn't exist. So you could see it from the graph, and you could see it when you put it into the equation. So you have none. Okay, so here's number 6. The base is 2, so you have these reference points. This is the transformation that they're going to go through, and here are the points. Okay, this is your h, your a, and your k. And then this is the parent function log base 2 of x. So compared to this function, g of x has a vertical compression by a factor of 1/2. And then the translations is going to be 1 to the right and 2 down. So that's how you describe the changes. Okay, so I'm going to draw the vertical asymptote right here. Now I'm going to plot the points 1 and 1/2, negative 2 1/2, so about here, 2 negative 2, 3 negative 1 1/2, so about here. Okay, so there's g of x. So the domain from 1 to infinity, the range is all reals, horizontal asymptote x equals 1, and behaviors as x goes to infinity, f of x also goes to infinity, and as x approaches 1 from the right, f of x goes to negative infinity. the x-intercept and y-intercept. So for the x-intercept, you make g of x equals 0, so and the 2 you move over, so you end up with 2 equals 1/2 log base 2 of x minus 1. We multiply by 2 to get rid of this, so you end up with a 4. That's parentheses. So this is 2 to the 4th equals x minus 1, so that's 16 equals x minus 1. You add a 1, so the x-intercept is 17. For the y-intercept, again it has none. So here again, here are the reference points. Because it's natural log, the base is e. These are the transformations, and then this is what you end up with. Now this is the exact value. When you plug it in a calculator, you get 4.4. This is the exact value. When you put it in a calculator, you get 6.7. To describe the transformation, you would say it's compared to ln x to this function right here, the one that I have on the graph. G of x, it has a vertical stretch by a factor of 4. It reflects over the x-axis because of the negative, and then the translations are 4 to the right and 3 up. Okay, so now I'm going to plot the points. So it is vertical asymptote is going to be at 4. And then we have 4.47 about here, 5.3, 6.7, -1. So it goes something like this. Okay, that's your g of x. So the domain is from 4 to infinity. The range is all reals. Horizontal asymptote is x equals 4. The end behavior, as x goes to infinity, f of x goes to negative infinity. As x goes to 4 from the right, f of x goes to infinity. The x-intercept, replace the x with a 0 and subtract the 4. So you, after you do all that, you get, I'll put it here on the top, you get 3/4 equals natural log of x minus 4. And so that's e to the 3/4 equals x minus 4. So then the exact value would be 4 plus e to the 3/4. And so when you put in a calculator, you get this, and then y-intercept, it has none because there's nothing on this side. Okay, the graph doesn't go beyond this yellow line. Okay, so here's the whole thing for number 8. The reference points, the transformed points, the description of how we got g of x from f of x, right here. Vertical stretch, factor of 2, reflection over the x-axis, translation left 2 and 5 up. Domain, range, and horizontal asymptote, the end behaviors, and then here's the work for the x-intercept. Again, make this one a 0 and then move the 5 over, divide by 2, -2, change it to exponential, and then plug it into a calculator, and this is what you get, 314. And you could tell because it's kind of flat, it's going down very slowly. And then for the y-intercept, you make the x equal to 0, and here you see it here, and then simplify and you put this into the calculator, and you get 4.4.